Today in this video, I am going to explain some important sums based on some basic trigonometrical concepts. So first one is prove that cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. So let's do it. Let's take left hand side. Now cosec theta is the reciprocal of sine theta, so we may write it as 1 upon sine theta minus, and cot theta is equal to cos theta upon sine theta, so we may write it as cos theta upon sine theta and whole square. So basically we have written cosec theta and cot theta in terms of sine and cos. Now within bracket we get the LCM sine theta, and in the numerator we have 1 minus cos theta whole square. So we may write it as 1 minus cos theta whole square upon sine square theta. Now it may be written as 1 minus cos theta as it is sine square theta plus cos square theta is equal to 1. So if we transpose cos square theta to right hand side, we get sine square theta is equal to 1 minus cos square theta. So in place of sine square theta we write 1 minus cos square theta. Next, 1 minus cos theta as it is whole square upon, here as you know 1 may be written as 1 square, so it is 1 square minus cos square theta, that means in the format of a square minus b square. So we may apply a square minus b square formula, which is equal to a plus b, a minus b, so we may write it as 1 plus cos theta into 1 minus cos theta. Now here this bracket 1 minus cos theta will cancel 1 power of 1 minus cos theta in the numerator. So we get 1 minus cos theta in the numerator, and in denominator 1 plus cos theta, which is exactly equal to right hand side of the expression to be proved, that is 1 minus cos theta upon 1 plus cos theta. So this is equal to right hand side and hence proved. Now the second sum is prove that cos a upon 1 plus sine a plus 1 plus sine a upon cos a is equal to 2 sec a. So let's do it. Let us take left hand side. Now taking LCM, we get in denominator 1 plus sine a into cos a. So dividing LCM by 1 plus sine a, we get cos a will multiply cos a, and we get cos square a, plus then we divide this LCM by cos a will divide cos a, and we get 1 plus sine a, that will multiply 1 plus sine a, so we get 1 plus sine a whole square, 1 plus sine a whole square. Now cos square a as it is, plus opening this bracket by a plus b whole square formula, we get 1 square, that is 1 plus sine square a, plus 2 into 1 into sine a, that is 2 sine a, upon 1 plus sine a cos a. Now as we observe, cos square a plus sine square is there, so we should collect them. Cos square a plus sine square a should be written together, and this plus 1 after that, then plus 2 sine a divided by 1 plus sine a into cos a. As we know well, cos square theta plus sin square theta is 1. So cos square A plus sin square A is 1. So we get 1 plus that one as it is plus 2 sin A divided by 1 plus sin A into cos A. Now 1 plus 1, 2 plus 2 sin A divided by 1 plus sin A into cos A. Now taking 2 common out of these two terms, we get 2 bracket 1 plus sin A divided by 1 plus sin A into cos A. As we observe, 1 plus sin A is in numerator, and in denominator we have the same expression 1 plus sin A. So these two expressions are cancelled with each other, leaving 2 in the numerator and cos A in denominator. And as we know well, cos is the reciprocal of sec and sec is the reciprocal of cos. So 1 upon cos A may be written as sec A. So 2 upon cos A may be written as 2 into sec A, which is exactly equal to right hand side. So we have proved the given condition. Now third sum is prove that tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta into cosec theta. So let us take left hand side. Let us write all these trigonometrical ratios in terms of sine and cos. So as we know well, tan theta is equal to sine theta upon cos theta. So we write sine theta upon cos theta in place of tan theta, and in denominator 1 minus as it is, and cot theta may be written as cos theta upon sine theta. Then plus cot theta, again cot theta in terms of sine and cos, that is cos theta upon sine theta divided by 1 minus tan theta may be written as sine theta upon cos theta. In the next step, in the numerator we write sine theta upon cos theta as it is, and in denominator we may take sine theta LCM, and we have in the numerator sine theta into 1 sine theta minus sine theta will divide sine theta, we get 1 will multiply cos theta, so we get minus cos theta, plus here cos theta upon sine theta as it is, and in denominator we take LCM cos theta, so we get cos theta minus sine theta. Now as we know well, the denominator of numerator goes in the main denominator and denominator of denominator goes in the main numerator. So this sine theta will go in the main numerator. So we get sine theta into sine theta. When this sine theta goes in the main numerator, it will multiply this sine theta, and we get sine square theta divided by, and this cos theta comes down, so cos theta, and in the bracket sine theta minus cos theta. Similarly, here sine theta goes in the main denominator and cos theta goes in main numerator, multiplying cos theta. So here cos theta into cos theta becomes cos square theta upon, here in denominator we get sine theta from here, and in the bracket cos theta minus sine theta. Now sine square theta as it is upon cos theta as it is, sine theta minus cos theta as it is. There is no change in this expression. In this expression, in the bracket cos theta minus sine theta, we should take minus common out of it. so that this bracket becomes identical to this bracket, because difference between these two brackets are sine theta minus cos theta is there, and there is cos theta minus sine theta. That means the difference is only of the difference of signs. So to make them identical, we have to take minus out of this expression. So we get cos square theta as it is, upon, when we take minus out of it, we get minus sine theta, because plus minus into plus minus sine theta, and now inside the bracket we get sine theta minus cos theta. Now this minus will multiply this plus, and minus into plus is minus, as you know well. So this expression turns out to be sine square theta upon cos theta sine theta minus cos theta minus cos square theta upon sine theta minus cos theta. Forgot to write sine theta over here, because there was sine theta outside, and then this expression. Yes. So if we take LCM of these two denominator, we have sine theta into cos theta, these two trigonometrical ratios outside of the bracket, and this bracket is common. So this is LCM, and now we have to divide this LCM by this denominator. So cos theta will be cancelled, sine theta minus cos theta will be cancelled, only sine theta is left, and this sine theta will multiply numerator sine square theta, that will be sine cube theta, minus, here now we have to divide LCM by this expression. So sine theta will cancel sine theta, and sine theta minus cos theta will cancel sine theta minus cos theta, and we are left with cos theta. That cos theta will multiply cos square theta in the numerator, so we get cos cube theta. Now proceeding from this step, so now this is in the format of a cube minus b cube. So using formula a cube minus b cube, we may write it as sine theta minus cos theta into sine square theta plus cos square theta plus sine theta cos theta, sine theta cos theta, because a cube minus b cube is equal to a minus b bracket a square plus b square plus ab. So in denominator we have this bracket is identical to this bracket, and these are in numerator and denominator, so we may cancel them, and in the bracket we get sine square theta plus cos square theta, which is equal to 1, so that is 1, and the next term is sine theta into cos theta, that is written as it is. So simply in the numerator we have 1 plus sine theta into cos theta, and in denominator we have sine theta into cos theta. Now we may split these terms as so the sine theta will be cancelled by sine theta, and cos theta will be cancelled by cos theta in this term, and the reciprocal of sine is cosec and reciprocal of cos is sec. So 1 upon sine theta cos theta may be written as cosec theta into sec theta plus 1. So as addition and multiplication, both operations are commutative, so we may write this expression as 1 plus sec theta into cosec theta, which is exactly equal to the right hand side of the equation to be proved. So this is equal to right hand side, and hence proved. Now the fourth sum is proved that 1 plus sec a upon sec a is equal to sine square a upon 1 minus cos a. So let us take left hand side. Now write sec a in terms of cos. So if we write sec a in terms of cos, it will be 1 upon cos a, because cos is the reciprocal of sec and vice versa. So we get 1 plus 1 upon cos a upon 1 upon cos A. Now if in the numerator we take cos A LCM, in the numerator we get cos A plus 1 divided by here 1 upon cos A as it is. So both the denominators are identical, so we may cancel them. So ultimately in the numerator we have cos A plus 1 and in denominator we have only 1. Now multiplying numerator and denominator by 1 minus cos A. So obviously in the numerator we have the situation 1 plus cos A into 1 minus cos A, which is identical to A minus B, A plus B, which is equal to A square minus B square. So using that formula we may write them as 1 square minus cos square A divided by, in denominator, 1 into 1 minus cos A is equal to 1 minus cos A. So it is equal to 1 minus cos square A, because 1 square is 1 and minus cos square A as it is. So 1 minus cos square A and 1 minus cos A in the denominator. As we know well, 1 minus cos square A may be written as sine square A, as sine square theta plus cos square theta is equal to 1. So if we transpose cos square theta to other side, we get sine square theta is equal to 1 minus cos square theta. So using that formula, we may write 1 minus cos square A as sine square A upon 1 minus cos A. So we get exactly the right hand side of the equation to be proved, sine square A upon 1 minus cos A. Here we have sine square A upon 1 minus cos square A. So this is equal to right hand side, and hence we have proved the given equation. Now the fifth sum is proof that cos A minus sine A plus 1 upon cos A plus sine A minus 1 is equal to cosec A plus cot A. So let us take left hand side. Cos A. If we take minus common out of these two terms, we may write it them as minus bracket sine A minus 1 divided by, in denominator cos A as it is, plus, and we may write these two terms in the bracket sine A minus 1. Now in the next step, this expression is written as it is then we multiply numerator and denominator by cos A minus sine A minus 1. So in the numerator we observe we have the same expressions in multiplication, so that will be whole square of the expression divided by, in denominator we observe that this is the condition of A plus B A minus B, because cos A 1 sine A minus 1 sine A minus 1, but there are opposite signs between these two expressions, plus is here, minus is here. So the same situation as A plus B A minus B. So we may use A plus B A minus B formula, which is equal to A square minus B square. So using that formula we may write them as cos square A minus bracket sine A minus 1 whole square. Now opening this expression by A minus B whole square, we get cos because we had taken this term as A and this term as B. So A minus B whole square will be cos square A square plus B square minus 2AB, that is twice of product of these two. In denominator, cos square A as it is minus, here we may use the formula of a minus b whole square, taking sine a as a and 1 as b, so it is the format of a minus b whole square. So using the formula we may write them as sine square a plus 1 minus twice sine a. Now in the next step, cos square a as it is plus, here again sine a minus 1 whole square may be expressed as sine square a plus 1 minus twice sine a minus 2 cos a sine a minus 1. In denominator, cos square a, and open this bracket, all the signs will be changed because of this minus outside the bracket, minus sine square a minus 1 plus 2 sine a. Now in the numerator we have cos square a plus sine square a, which is equal to 1, so we write 1. Next plus 1, so plus 1 as it is, and here we have minus 2 sine a, and the next term as it is 2 cos a bracket sine a minus 1 divided by, here cos square a may be written as 1 minus sine square a, and this minus sine square a as it is minus 1 plus 2 sine a. So in the numerator, here we have 1 plus 1 2, so 2 minus 2 sine a, and taking minus common out of this bracket, this minus becomes plus, and the sign of these two terms will be changed, and we may write them as 2 cos a as it is, and we may write them as 1 minus sine a because we had taken minus 1 common, divided by, here positive 1 and negative 1 cancelled out, and 2a sine a is positive term, so we better write it first, 2 sine a, and then minus sine square a minus sine square a becomes minus 2 sine square a. Now in the numerator, out of these two terms we may take 2 common, so in the bracket we get 1 minus sine a plus 2 cos a 1 minus sine a divided by, here in denominator 2 and sine a are common out of these two terms, so we should take 2 sine a common out of these two terms. We get in the bracket 1 minus sine a. Now proceeding from this step, as it is clear, 1 minus sine a is the common expression in the numerator, so we may take 2 1 minus sine a common. So in this term we get 1, and in this term we get plus cos a divided by 2 sine a bracket 1 minus sine a. Obviously 2 is cancelled by 2 and 1 minus sine a is cancelled by 1 minus sine a, and we get 1 plus cos a upon sine a. We may split them up as 1 over sine a plus cos a upon sine a. So quite clear, 1 upon sine a may be written as cosec a because sine is the reciprocal of cosec, and vice versa. So 1 upon sine a may be written as cosec a plus cos a upon sine a may be written as cot a. Now the next sum is prove that under root 1 plus sine a upon 1 minus sine a is equal to sec a plus tan a. So let us take left hand side. One plus sine a upon 1 minus sine A, multiply numerator and denominator within the root by 1 plus sine A. So in the numerator we have 1 plus sine A plus into 1 plus sine A, that is 1 plus sine A whole square, and in the denominator we have 1 minus sine A into 1 plus sine A, which is the situation of A plus B, A minus B, that is equal to A square minus B square. So using that entity we may write it as 1 square minus sine square A. So in the numerator this square will cancel the root, so we have 1 plus sine A. In denominator we have under root 1 minus sine square A. So 1 plus sine A upon under root, as we know well, 1 minus sine square theta is cos square theta, so 1 minus sine square A may be written as cos square A. And here again this square will cancel the root, so we have 1 plus sine A upon cos A. Now since the cos A is the common denominator of both the terms, so we may split expression into 1 upon cos A plus sine A upon cos A. As we know well, the reciprocal of cos is sec, so 1 upon cos A may be written as sec A, and sine A upon cos A is equal to tan A, so we have sec A plus tan A, which is exactly equal to the right hand side of the expressions to be proved. So now the seventh sum is sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. We have to prove this equation. So let us take left hand side. As we see, sine theta is common out of these two terms, so we should take sine theta common out of them. We get in the bracket 1, in this term 1 minus 2 sine square theta divided by, in denominator we have cos theta common, so taking cos theta common out of them we have 2 cos square theta minus 1. Now as we know, sine theta upon cos theta becomes tan theta, so we may write it as tan theta, and in the numerator we have 1 minus 2, and we may write sine square theta as 1 minus cos square theta. In denominator 2 cos square theta minus 1. Now tan theta, if we open this bracket up, we have 1 minus 2 minus into minus plus 2 cos square theta divided by 2 cos square theta minus 1. So tan theta into, if we simplify this, 2 cos square theta is positive term, so we better write it first, 2 cos square theta, and 1 minus 2 is minus 1, so minus 1 upon, in denominator we have already 2 cos square theta minus 1. These two brackets are identical, so are cancelled with each other, and we are left with only tan theta, which is equal to right hand side. The next sum is prove that sine A plus cosec A whole square plus bracket cos A plus sec A whole square is equal to 7 plus tan square A plus cot square A. So let us take left hand side. Now opening this bracket by A plus B whole square formula, after that plus, and opening this bracket by the formula A plus B whole square, Now rearranging the terms, we may write sine square theta plus cos square theta within a bracket all together, and we should group cosec square A plus sec square A, then plus, after that these two terms are left. Here sine A into cosec A becomes 1 because sine is the reciprocal of cosec A and vice versa. So product of sine A and cosec A must be 1. Since we may write cosec A as 1 upon sine A, or we may write sine A as 1 upon cosec A. In both the cases the product is 1. So here 2 is left. Similarly, cos A into sec A is equal to 1, so again plus 2. Here, as we know, sine square A plus cos square A is 1, so we may write 1 plus cosec square theta is 1 plus cot square theta, so we may write cosec square A as 1 plus cot square A, plus sec square theta is equal to 1 plus tan square theta, so sec square A may be written as 1 plus tan square A. And then after that 2 plus 2 becomes 4, so 1 plus 1 plus 1, 3 plus 4, 7, we write 7 plus, then we may write tan square A because addition is commutative, so tan square A plus cot square A. We may also write cot square A first and then tan square A. It makes no difference because addition is commutative, but we have written in the same form as it is given in the sum as right hand side in the same order, 7 plus tan square A plus cot square A. So we have arranged all the terms in the same way, 7. Then the next sum is prove that cosec A minus sine A into sec A minus cos A is equal to 1 upon tan A plus cot A. So let us start with the left hand side. Now we may write cosec A as 1 upon sine A and minus sine A as it is, and here in the second bracket sec A may be written as 1 upon cos A and minus cos A as it is. Now taking LCM sine A, we get 1 minus sine square A in the numerator. In second bracket taking cos A, LCM, we get 1 minus cos square A. So as we know, 1 minus sine square theta is cos square theta, so we get cos square A upon sine A into 1 minus cos square theta may be written as sine square theta. So sine square A upon cos A. 1 minus sine square cos square A is equal to sine square A, so we have written sine square A in the numerator in place of 1 minus cos square A, and in denominator it was cos square A already. So this cos A will cancel 1 power from the numerator and this sine A will cancel 1 power from numerator. So we have in the numerator cos A into sine A. Now multiplying numerator and denominator by tan A plus cot A. Cos A into sine A will multiply both the terms inside if we open up the bracket. So we have cos A into sine A into tan A plus cos A into sine A into cot A divided by, in denominator, tan A plus cot A. In the numerator, cos A into sine A as it is, and now tan A may be written as tan sine A upon cos A. Tan A is equal to sine A upon cos A. So tan A is written as sine A upon cos A plus In the second term, cos A sin A as it is, and cot A may be written as cos A upon sin A divided by tan A plus cot A. So we have sin A into sin A, sin square A plus cos into cos, cos square A upon tan A plus cot A. As we know well, sin square theta plus cos square theta is 1. So sin square A plus cos square A is equal to 1. And in denominator we have tan A plus cot A. So we have the right hand side of the expression 1 upon tan A plus cot A. So we have proved the left hand side is equal to right hand side, and hence proved. Now the next and the last sum of this video is to prove 1 plus tan square A upon 1 plus cot square A is equal to bracket 1 minus tan A upon 1 minus cot A whole square is equal to tan square A. So let us take the first expression. As we know well, 1 plus tan square theta is sec square theta and 1 plus cot square theta is cosec square theta. So 1 plus tan square A may be written as sec square A, and 1 plus cot square A may be written as cosec square A. Since the reciprocal of sec is cos and reciprocal of cosec is sine, so we may write sec square A as 1 upon cos square A and cosec square A in denominator as 1 upon sine square A. So this sine square A being the denominator of denominator goes in the main numerator, and this cos square A being denominator of numerator goes in the main denominator. So this goes up and cos square A goes down. So we have sine square A upon cos square A, which is equal to tan square A, because sine upon cos is 10. So sine square A upon cos square A is equal to tan square A. Let it be equation number 1. Now take the second expression, that is bracket 1 minus tan A upon 1 minus cot A. In this expression, 1 minus tan A may be written as sin A upon cos A, and in denominator 1 minus cot A may be written as cos A upon sin A whole square. Now in numerator within the bracket we may take cos A LCM, and in numerator we have cos A minus sin A divided by, in denominator we may take sin A LCM, having in numerator sin A minus cos A whole square. So this cos A goes in the main denominator and this sin A goes in the main numerator, and we may take minus common out of this expression cos A minus sin A. So we may write minus sin A, because sin A goes in the main numerator, so sin is there, and we have taken minus common out of these two terms, so we take minus outside, and then inside the bracket there will be sin A minus A, because taking minus common we get sin A minus cos A. Signs of sin and cos will be changed, and upon cos A goes in the main denominator, so cos A goes there, and sin A minus cos A as it is, sin A minus cos A as it is, and there is whole square of the bracket. As we see, sin A minus cos A is there in the numerator and sin A minus cos A, the same expression in the denominator. So these two expressions are cancelled with each other, leaving inside minus sine upon cos, which is equal to 10. So minus 10a whole square, and squaring we get 10 square a, because square of minus 1 is plus 1. So it becomes 10 square a. Let it be equation number 2. So if we observe equation number 1 and equation number 2, we have the value of 1 plus 10 square a upon 1 plus cot square is equal to 10 square a, and the value of 1 minus 10a upon 1 minus cot a whole square is also equal to 10 square a. So we may conclude from equation number 1 and 2 that 1 plus 10 square a upon 1 plus cot square a is equal to bracket 1 minus 10a upon 1 minus cot a whole square is equal to 10 square a, and hence we have proved the given condition.